18.9 seconds, the transfer displacement y on the this problems are at the 18.9 seconds, the transfer displacement y on the element of string at the h equal to 0.245 meter is 1.92 millimeter. So what is the u? Now u is the transfer velocity of the string element. So the normally the transfer displacement can be calculated by formula yh is equal to y maxima psi kh minus omega t. So this is the equation. Y is equal to y maxima psi kh minus omega t. In this case, our transfer velocity is u. U is a dy by dt. So dy by dt can be calculated. So dy by dt y maxima psi kh minus omega t. So you differentiate the psi. So that will be minus yn coming out. Signs are differentiate. Sign will be minus cos kh minus omega t. And also that this is that this becomes a dy by dt kh minus omega t. So this is also a by also that this one also this omega also coming out. So this will become as a minus yn omega cos kh minus omega t. So this is for us u can be calculated. U is equal to minus yn omega cos kh minus omega t. Okay, so yn is also have to be given in the program. So the strings are at the 18.9 seconds. So this one will just transfer y is already given here. So this is for the equation u can be calculated by this equation. So 18.9 seconds transfer y of the string at the 0.2 meter in 1.92 millimeter. So what is the u? So we calculate u is this equation. Angular velocity and this is for the mu and the power in the string can be calculated. Dk is equal to half into. Next one is the energy and power of the wave traveling along a string. So the wave is traveling along a string equal to 3 energy. One is the kinetic energy. Because the wave is moving, so that if they also possess the kinetic energy. Analyze the electric potential energy. Electric potential energy means this is a string is elongated. So if we retain as a energy, when the string is elongated, so it's retaining energy. So that this energy is we make the string to go back to the original position. Now is the energy transport. So there are 3 kinds of energy in the string. So kinetic energy is electric potential energy and the energy is transport. So we can also calculate the rate of the energy transmission. Rate of the energy transmission can be calculated by the formula. Rate of energy transmission. The formula to rate of energy is a rate of change. Rate of energy means the energy scale. Rate means the dk. Dk can be calculated. Dk is equal to half into dn into u square. D is a mass and the u square is a velocity. So this is what is half into dm into u square. Means the mass u is a velocity. D is a rate of change. And dk is a kinetic energy change. Can be calculated by this formula. In the midnight hour, there's dk by dt. They are the energy change at the average time can be calculated. The formula is a 1/4 into UB omega square into YM square. This is the equation. It's similarly the average power can also be calculated 2 into dk by dt. So the average power. So therefore the average power in the kinetic. The string, the energy power in the string can be calculated half into UB omega square YN square. So this is the mu is the wave length, V is the velocity, and omega is the angular velocity, and this is for the mu is the YN is the maximum distance, maximum amplitude of the string. So then we can also calculate the rate of the energy in the string is a dk is equal to half into dmu square. Also there's a power related by the string is a half into mu b omega square into ym square. Always usually the longitudinal wave. So this one is a oscillation parallel to the direction of the wave travel. When the wave travel, this is for the direction of the wave. And also this is oscillation. So oscillations are the parallel to the wave, then we will have longitudinal wave. Some waves are the particle wave transfer wave. When the wave is travel, so this is all the wave direction, and oscillation are happening here. This way the transfer wave. So here is the wave and the oscillation are parallel, so the longitudinal wave. And therefore, some ways usually the longitudinal wave, the wave direction, and also the oscillations are the parallel. So this is the longitudinal wave. So the velocity can also be calculated. The velocity v is equal to the square root of the r by mu. So this is square root of r is the elastic property and initial property. Elastic. Inertial property. So elastic property divided by the inertial property square root. So this is what is the velocity. The speed of the transfer wave along the change. Speed of transfer wave. Transfer along the string. So speed of the transfer along the string is the square root of the elastic property divided by inertial property. And speed of the sound, in this case we can also calculate the speed of the sound, v is equal to the v by p. So this is the v is the speed of the sound. And v is the bulk modulus. Modulus means how the compression changing. When the sound is moving in the surface region, so depend on the pressure and the velocity, the effect are changing. So this is the bulk modulus v is equal to minus delta p divided by delta v by v. This means the sound velocity and the sound pressure ratio. So this is what is a change in the pressure. Change in the pressure. This is what is a velocities are change, specific velocity change. Then you can calculate the P. P means this is the equation that forming this equation is pressure and the velocity. So the pressure of this region. So in this case, sound wave velocity is depending on the pressure. Pressure of the region through which the sound waves are passing, and also the volume of the region through which the sound waves are passing. So those things are the influence the velocity of the sound. And so this V can be calculated minus the delta P by the delta V by V, and also the P is the pressure. By this way, we can calculate the sound velocity. Sound velocity is depending on the region. So when the sound is passing through, some regions are depending on the density. When density is high, density is low, it can determine the weight of the sound. So normally the sound is there is a noise in media, especially on the moon that the sound cannot pass through because there is no air. Sound can only pass through the air because the sound air is called the pressure and the volume of the media, so the sound can pass through. But there is no air, so sound cannot pass through. So sound velocity is mostly depending on the in media through which the sound is passing through. The next one is light and photon. When the light is fall on the one surface, so this is the incident angle. Theta 1 is the incident angle. So turn on the light. So this is the light beam. Light beam fall on the surface. So the theta 1 is the incident angle. And then this sound of the light will be reflected. So this is for the theta 2. So reflected angle, reflection angle. So some of the sound are we go into the passing through this here. So this is the reflection angle, theta R. Theta R is a reflection angle. So theta 1, theta 2, and theta R are the light photon. So when the light passing through the region, some of the reflected sound of the going through the region. So that we can write down the here. This is the N1 region and the N2 region. So that the velocity of the sound lies in the N1 region and the sine theta 2. So this is for the N1 into sine theta 1 is equal to the N2 into sine theta 2. So for the reflections N1 into sine theta 1 is equal to N2 into the sine theta 2. And these are reflection or the reflection. So we can calculate N1 into the sine theta 1 plus is equal to N2 into sine theta 2. So we can calculate. So this is for this angle here. So 50 degrees. They hit the material 1. And they pass into the material 2 and the finally they are going to the material 3. So material 3 with the air. In this case, the density of the material 1 is N1 is 1.33 and 2 is 1.77 for the A is N3. N3 is equal to that 1. So firstly we have to calculate the incident angle theta 1. Theta 1 is can be calculated. Theta 1 is incident angle. So incident angle can be calculated as 90 minus 50. So this is 40 degrees. 40 degrees is theta 1. So we write down the equation N1 sin theta 1 is equal to N2 sin theta 2. N1 sin theta 1 equal to N2 sin theta 2. So N1 is we can calculate 1.33. Sin theta 1 is sin 50 equal to N2 is 1.77 and the sin theta 2. So now you can calculate. So this is the sin theta 2 is equal to 1.33 by 1.77 sin 50. The theta 2 can be calculated. Sin inverse 1.33 by 1.77 into sin 50. So by this is the angle theta 2 is around 29 degrees. Theta 2 is 29 degrees. After the theta 2, this angle theta 2 this also the angle theta 2. The same. So theta 3 can also be calculated. So this is for the N2 sin theta 2 is equal to N3 sin theta 3. So the N2 is 1.77 and then beyond the media is 1.77 and sin theta 3 sin 29. And then beyond the A is N3. N3 is 1 and then we have to calculate sin theta 3. So the sin theta 3 is equal to 1.77 into sin 29. So the theta 3 is equal to sin inverse 1.77 multiplied with sin 29. The theta 3 can be calculated, theta 0 is 59 degrees. Likewise, light. Light can be that we assume as a quantum. Photon and a quantum on light. Quantum on light means that it's a light based on the waves of principle. Wave has velocity and also the wavelength and the frequency. So that all the light are that we assume as a wave, electromagnetic wave. So that each gets a wave velocity and the wavelength and the wave frequency. Those things are related by quantum physics. The quantum physics is this is the velocity of the light. We concern about this is for the wave nature. Frequency F is equal to the C divided by A. C divided by lambda. So this is for the F is equal to the wave frequency. And C is equal to the velocity of the light. And lambda is a wavelength. So F is the wave velocity, wave frequency, C is the velocity of the light, and the lambda is the wavelength. In the meantime, we also calculate for the E, photon energy. E is equal to H multiplied by F. E is the photon energy. And then also H is equal to Planck constant. So H is the Planck constant. H value can be calculated as 6.63 into 10 power minus 4 kilosecond. Those are the equation for the photon. So in this case, the light can be assumed as a magnetic wave, electromagnetic waveform. So that equal to the frequency F is C divided by lambda. C is F is the wave frequency, C is the velocity of light, lambda is the wavelength. In the meantime, E is the photon energy can also be calculated, H multiplied by F. H is the Planck constant and F is the frequency of the wave. So they can also be calculated. A sodium bivalent is placed at the center of the last sphere, set across the all light reaching it. So this is for the last sphere. So this is for we use the light. So the energy is 100 watts. Assume that the emission is entirely at the wavelength of the 590 nanometer. What rate are the photon absorbed by the sphere? So in this case, we have to calculate emission rate. Emission rate is equal to the rate of energy emission divided by energy emitted by emitted photon. So this is rate of energy. Emission divided by energy by emitted photon. This is we can also calculate. In the meantime, therefore the energy by emitted photon, rate of energy by emission is this is the rate of change. Rate of the energy, the power. Power is the energy, so power emit. Energy by emitted photon. So H multiplied F. So this is the energy by emitted photon. Can we calculate H multiplied F? So the rate of the energy is the power. Power is the P image. Divided by energy by the emitted photon is the H multiplied F. So we substitute here. So in this case, we calculate. So in this case, so F is equal to that we also know as P by lambda. So that we calculate P image divided by H into C by lambda. So this is the P image multiplying lambda divided by H into C. So the emitted power is that we already know that 100 watts. So this is 100 and multiply. Lambda is the wavelength. So 590 in nanometer. 590 into 10 power minus 9. Alright, H is the Planck constant, 6.63 into 10 power minus 34. And C is so light velocity, 3 into 10 power 8. So by solving this one, there will be 2.97 into 10 power 20 photons. Photons per second. So this is for the power equations that we can calculate by this way. Next topic is the photoelectric equation. When the light fall on the solar panel, so it will convert to the electrical energy. So we can write down the equation for the solar panel electrical energy. H into F is equal to K maxima plus pi. In this case, H is the Planck constant, F is the frequency, K is the maximum energy, and pi. The pi is for the minimum energy to escape the electron. So this is for the pi is equal to minimum energy required to emit the electron. So this is the sound wave. When the sound wave is fall on the surface, the sound wave for the frequency and the Planck constant. Because the sound wave energies are the electrons in the process are emitted. So the pi is the minimum amount of the energy required to emit the electron, and so those electrons plus energy, kinetic energy maximum, the rest it will produce the electricity flow in the solar cell. So therefore the H is equal to K maximum plus pi. This is the photoelectric equation. In the meantime, when the velocity, when we are destroying the velocity, sometimes we have to put the stopping potential. Stopping potential, we provide the potential so that potential stop the electron flow. So that stopping potential can also be calculated. V stop, this is the stopping potential. So V stop can be calculated. It's equal to the H by E into F. So now the H by E into F minus pi by E. So this is what E is the number of electrons are voltage value, E electron voltage, and H is the Planck constant, F is the frequency, and pi is the minimum energy required to emit the electron. So those things are can be calculated. Therefore, the elementary charge E, based on the elementary charge is we can calculate the H. H is equal to the 4.1 into 10 power minus 15 per second multiply with the 1 electron got the 1.6 into 10 power minus 19 coulomb. So therefore this will be the 6.6 into 10 power minus 34 joule per second. This means that to produce the electron, it needs to apply the 6.6 into the 10 power minus 34 joules. So that by applying the 6.6 into the 10 power minus 34 joule, every electron can be coming out. So this is for the energy required to emit the electron. So this principle is utilized in the solar cell design. In the solar cell design, the sun is the energy. Sun energy excites the electron. So that because of those energy, electron absorb the sun energy and they coming out. So this each electron requires the 6.6 into 10 power minus 4 joules energy. A potential pi is the distance r equal to 3.5 meter from the isotropic light source. So this is the light source. And this is for the potential pi. So when the phase emit the light, so this potential pi will absorb the light and then will emit the electron. So we have to calculate the time required to emit the electron. Time required to make the absorption, and not to emit the electron. In this case, this point is the distance is 3.5 meter distance. Okay, so the time can be calculated. Delta T is the time is equal to the delta E, change of the energy divided by absorbed power. So this is the P absorption. So this is called the delta T is the time, delta E is the change of energy. P is the absorbed power. The time can be calculated, change of the energy divided by absorbed power. So this is what so delta E by P absorbed, so this is the delta T. In this case, the change of the energy is a minimum watt. This one is a minimum watt. Minimum what? Minimum energy required to minimum energy required to emit the electron. So in this case, delta E is the minimum energy required is 5. So delta T can be calculated. Delta T is equal to 5 divided by P absorption. So have to be calculated. Okay, power. Power is the current multiply the area. So this is called the power. This is called I multiply A. I is the intensity, light intensity. This is so this power absorbed power is a light intensity multiply area. I multiply A. I is the light intensity. A is the area. So the I multiply A is light intensity multiply the area. So that we have to calculate the I is equal to the so I have to calculate I is equal to the emitted power by 4 by R square. So this is what is the emitted power. I can also be calculated. I is equal to emitted power. P emit divided by 4 by R square. So in the place of the I we can substitute. And therefore the delta T is equal to 5 divided by P emitted power divided by 4 by R square into A. So therefore the delta T can be calculated 5 divided by the 4 by R square. 5 divided by the emitted power multiply A. Okay, then we now substitute here. R value is this is for the 355 meter is R. So 355 substitute. And also we have to calculate the 5. 5 requirement is 355 into 10 power minus 19 joule. So the 5 that usually that we calculate is 355 into 10 power minus 19 joule. And emitted power is light. Light power is only given the 1 by 5 watts. Light. The power is there is 1 by 5 watts. Can substitute. Area A is also given 755 into 85 into 10 power minus 20 watts a meter square. So those things have to be substitute. Then we can create the delta T. So this is the area A of the electron can also be calculated. A is equal to 7.85 into 10 power minus 21 meter square. So those things we substitute here. So 4 multiplied by 3.1416 R square is 355 square. Multiplied by the 5. The 5 is 355 into 10 power minus 19. Divided by emitted power. Emitted power is 1 by 5. The area is 10.85 into 10 power minus 21. So by solving this one, the time requirement is the 1.4580 seconds or 1/3 hour. 1/3 hour is required to emit the time enough to emit the energy to emit the electron. And then we also have to calculate the phi value. The phi value is going to again have formula H into F0. So in this case, H is a Planck constant 6.63 into the 10 power minus 34 joule second. Multiply. So this is what is F. F is the frequency. The frequency of the wave. The frequency of the wave is usually we take the 5.5 into the 10 power 14 half. So this is light wave. So by solving this one, the phi wave is 3.6 into 10 power minus 19 joule. Or the 1 joule is 1/6. So 1/6 or so the 1 joule is equal to 1/6 into the 10 power minus 19 electron volt. And therefore the 3.6 into 10 power minus 19 divided by the 1/6. So you got the 2/3 electron volt. So this is called enough energy required to be absorbed by the potassium flame, potassium 5, to emit the electron, and time requirement is 1/3 hour. from the momentum the photon can have to be calculated. The photon momentum is a P. This is a photon momentum. Is equal to Hf by C or the H by lambda. So this is for the equation to calculate the momentum of the photon. So Hf by C, H is a Planck constant, S is the frequency, and C is the light velocity, and the lambda is the wavelength. So photons are momentum can be calculated by Hf by C or H by lambda. The electrons are moving along the nucleus. This is the nucleus are positive nucleus, positive and zeros are neutron. Positive is the proton and the zero is neutron. So this is the nucleus. Nucleus, photon plus neutron. So this one is electron is rotating, moving around the nucleus. So those are rotating at the specific path. So depending on the path, they got the energy level. They are part 1, part 2, part 3 like this. So they are energy level. The electron which is located at the closest to the nucleus has the highest Polish energy. But electrons are far from the nucleus are the lowest energy. So this is called the photons are momentum. See the calculation of the energy level. The energy level E can be calculated. E is equal to A squared divided by 8n squared into the n squared. So this is for the H of Planck constant. A is the mass of the electron. A is the specific part. So this is the and also the and this is 1, 2, 3. Part 1, part 2, and part 3. E is the energy. So the electrons are moving around the nucleus. They retain the energy. So the energy E can be calculated. A squared divided by 8ml squared into n squared. A is the Planck constant, M is the mass of the electron, and also the N is the 1, 2, 3, so this is the number of the part. So that was that we can calculate the energy level of the electron. A is equal to the N lambda and 2. Lambda is the wavelength, N is the 1, 2, 3, the part number. So from here you can calculate L and we compute and hence depend on the number N, we can calculate the energy related by the energy absorbed by the electron to move around the nucleus. So the nucleus is surrounded by the electron. Electrons are moving the nucleus. So each electron called the momentum and the energy. The energy can be calculated by this equation. A squared by the 8 ml squared into n squared, and it's 1, 2, 3. Part 1, part 2, part 3 is the n. And is the mass of the electron. H is the Planck constant. And in this case, L has to be calculated as n lambda by 2. And this is 1, 2, 3 is a part number, and lambda is a wavelength. So this is the way that we calculate the energy absorbed by the electron to circulate the nucleus. So the energy level can also be changing. Because of the when the electron is jumping from the one part to another part, so when the electron is jumping in or the jumping out, the energy level can be changing. So this energy level can change when once the energy level is changed from the movement of the electron from the one part to another, it can emit the light or the it gets energy waves that produce. So this is the energy change. Energy change can sometimes the energy change for the photon cell. Energy change will produce the light, especially the photoelectric cell. Photoelectric cell, so that when the energy here, so that this is the light will be emitted. So the light emitting diode. Light emitting diode means that we keep the body, electrical body, so that because the electrical body, the electrons are jumping from the one part to another part, so the light will be emitted. So this is the LED, and then the based on this principle. And therefore the energy change is a delta E. This is energy change. Can be calculated as energy high energy minus energy low. So energy change is equal to E high minus E low. So energy change can be calculated by this formula. So this energy change is, and the energy change can happen because of the frequency. When the this nucleus they start off the external energy with the frequency S. they strike that the electron, so energy level will be changed. So this energy level change can be calculated H multiplied by S. H multiplied by H is the plus force, S is the frequency of the H standard wave. So then this is equal to E high minus E low. So delta E is equal to H multiplied by S, so the H E high minus E low. So by this result you can calculate for the change of the energy. So this is for the electron is confined to this one dimensional. If I have this potential energy, it is 100 picos meter. So in this case, what is the smaller amount of energy the electron can have? So electron can have the energy can also be calculated. The formula is E1. E1 is the smallest amount of energy. E is equal to H squared divided by ms squared into the n squared. So this is a general equation. A squared divided by the 8ms squared into n squared. So this is a general equation. So in this case, smaller amount is n equal to 1. N equal to 1, this is the ground state. Ground state of this is a smaller amount. So that this equation we substitute here. So this becomes as E is equal to E1 is equal to A squared plus 4Z squared 6.63 into 10 power minus 34 the whole square. Divided by 8ms squared. 8 mass of the electron is 9.11 into the 10 power minus 31 kilogram. And that's n squared. So n is only given 100 picometer. 100 picometer is equal to 10 power minus squared. 100 multiplied 10 power minus squared. So square. So by solving this, E1 is equal to 6.031 into 10 power minus 18 joules. So then E1 can be also calculated. After E1 into the n squared is equal to 1, so that this becomes 1 squared. So 6.031 into 10 power minus 18 joules. So this is what's up. Then we can also calculate this electron volt. So electron volt can calculate this E1 divided by 1.6 into 10 power minus 19. So then 6.031 into 10 power minus 18 divided by 1.6 into 10 power minus 19. So by solving this one, you got the 37.7 eV. So this is for the smallest minimum amount of the electron is 37.7 into 7 eV. So this is the first condition. And another one is how much energy must be transferred to the electron if it is making the quantum jump from the ground state to the second excited state. Ground state to second excited state is ground state is 1, second excited state is 3. So this is called 1 and 3 different. So the second ground state is E1. Second excited. So E3. So E3 can also calculate. E3 is equal to A squared into 8ms squared into 3 squared. So this is E3 can also calculate. E3 is equal to A squared divided by 8ms squared into 3 squared. Okay, so this is E3 minus E1 is a jumping. So delta is E31. E31 is E3 minus E1. So E3 minus E1 is A squared divided by the 8ms squared into 3 squared minus 8 squared divided by 8ms squared into 1 squared. So by solving this one, E is E31. Then this is a change on the state. So the 8 squared divided by the 8ms squared 3 squared minus 1 squared. So 8 squared divided by 8ms squared is we already call it 6.031 into the 10 power minus 18 multiplied 3 squared minus 1 squared is 9 minus 1 is 8. So that will be 4.83 into 10 power minus 17 joules. So delta E1 in the E31 in the electron volt can be calculated 4.83 into 10 power minus 17 divided by 1.6 into 10 power minus 19. So you got that 301 electron volt. So this is what we change it from the jumping from the 1 one path to the another path, so that the electrons are with energy can be changing, the energy can be calculated by the formula. Okay, so let's see. If the electron gains the energy from the jump from the energy level E1 to energy level E3 by absorbing the light, what light wave is required. So in this case, the energy is jumping. Energy jumping means we can also calculate the energy level jumping so that it will produce a light. So this is for the energy jumping. This electron here is this is the ground state, and this is the state. So they change it so the light will emit. When the electrons are moving from the one part to the another part, light will be emitted. So the light can be calculated. The light emitted as light wavelength is equal to the length of the light wavelength of the light is equal to AC divided by delta E. So this is lambda is equal to the wave of the light. H is the Planck constant, C is the velocity of the light, and the delta E is the change of the energy. So in this case, the change of the energy that we already know is 6.483 into 10 power minus 17. Planck constant H can be substituted 6.63 into 10 power minus 34. Velocity of the light is 3 into 10 power 8. So this is what we substitute before the wavelength. 6.63 into 10 power minus 34 multiplied with 3 into 10 power 8. Divided by 4.83 into 10 power minus 17. Okay, by solving this one, wavelength will be 4.12 into 10 power minus 9 meter. So this is for the typical case of photon problem. When the electrons are excited, they are moving from one, jumping from the one part to another part. Once they are jumping from the one part to another part, the energy level change. The energy level waves are emit the light. So that this is a light wavelength and the change of the energy can be calculated by the equation. The equations are the E squared to the A squared divided by 8ml squared to N squared, and also the lambda is equal to AC divided by delta E. So this problem at the 18.9 seconds, the transfer displacement of the element of spin at the H equal to 0.245 meter is like 1.92 millimeter. So why is it U? U is the transfer velocity of the spin element. So the normally the transfer displacement can be calculated. In the G1, G2, those are the applications. So those are electric field and magnetic field concepts they got the theory behind. So theory behind for the electric field theory and magnetic field theory, they are also included in the physics. Now I continue with another topic, electric field. Okay, electric field can be calculated when the electric charge possess the energy here. So this is the charge of the energy. So the electric field this is called field stress. So electrical force, this charge called electrical force divided this is electric field. So the E can be calculated F divided by the Q. F is the electrical force, and the Q is the amount of the electrical charge, particle, and the E is the electric field. So this is the electric force. Q is the charge, and E is the electric field. So electric field is calculated. So this is for the F divided by Q. So this is E is the electric field. So the electric fields are usually coming out from the surface here. This surface area. This surface is a plated. So there will be the two surfaces. This surface is a positive plate, positive charge on the display here, and this surface called negative charge. So the surface electric charge they are moving from the electric field from the positive to negative. The force is moving from positive to negative. So this is for the electric field diagram. So electric fields are normally those electric charges are we can place on the capacitor. Capacitor stores the positive charge and the positive plate and negative plate. So that those fields are the parallel. All the fields, the lines are the parallel on the one plate to the another plate. So that all the electric charges you can see the positive charge here. The positive charge fields are coming out from the positive charge. And for the negative charge, the fields are coming into the negative charge. So this is the electric field, electric line can be represented by the row diagram. So therefore, we can change the charge. There are two electric. The Q1 and the Q2 are the two electric charge here. The distance between the Q1 and Q2 is R. So we can calculate this F. F needs to be calculated. So the F is equal to this is the electric field between the two charge particles. The formula is 4 pi E0. E0 is the probability of the A multiplied with the Q1, Q2 divided by the R square. R is the distance between the two electric charge square. So there are many electric charges are added on the one position. For example, this positions are the display. This is the F1. So this is for the P1. This is F2 and F3. So here you can calculate the E total. E total need to be calculated. F total is equal to the F1 plus F2 plus F3. In the meantime, the E total can be calculated. This is a F1 by Q1 plus F2 by Q2 plus F3 by the Q3. So those are the E can be calculated. Here with this is Q0 is the 1 unit. So the E total is equal to F1 by Q1 plus F2 by Q2 plus F3 by Q3. Or there's E total is equal to the summation of the beta sum of the electric field E1 plus E2 plus E3. So this is beta sum of the all electric field can be calculated to the electric field in a particular place. The influence by the sum of the electric field. The next one is the flux of the electric field. So when the electric field is acting on the place, the flux will also be coming out. The flux of the electric field can be calculated. So this is the flux of an electric field. Flux of an electric field. Flux of the electric field is the summation of the all field strength multiplied with the area. So this is for the flux of the electric field. Flux of an electric field. Flux on the electric field can be calculated as this flux on the electric field is equal to phi equal to the summation E into theta A. So this is what is the sum of the electric field are the summation and multiplied with the theta A is the flux of the electric field. So can be calculated phi equal to summation E into theta A. So this summation into delta A also be calculated. Normally, how can you calculate the flux? This is a flux phi square to the integration E multiplied delta A. Gaussian surface. Electric flux through a Gaussian surface. Electric flux through a Gaussian surface. So electric flux with Gaussian surface can be calculated. Here is the integration of beta and the multiply A. So this is this area, this surface here. This surface area that we can calculate. This is this area, the whole area. The flux will be coming out is a phi. So this is the E. And this area is a dA. So the electric flux through the constant surface is the phi equal to the integration surface integrate. Surface integrate. This is the surface integrate. Surface integrate E multiplied A. So this is the surface integrate. Surface integrate multiply E into delta A. So this is the electric flux can be calculated. Potential surface. Those surface cause that gives the equal potential. So this is surface 1 and surface 2, surface 3. They call the equal potential. So this is V1, V2, V3 is a V1 equal to V2 equal to V3. Those are the surface 1, 2, 3 are the equal potential surface. All the surface for the equal potential, the voltage are equal, so this is we call the equal potential surface. So the next one is that we calculate the potential from the field. Calculating the potential from the field. Calculating the potential from the field. So we need to calculate the potential from the field. In this case, this field is one to another. So this is for the fineness of voltage minus the integer voltage. We coming from this point to point 1 to the point 2. So this is the integer point. This is Vi. Here is the final point, the Vs. So when we are moving from the one point to another point, the potential will be changing. So this changing of the potential can be calculated. So this voltage is changing. So the electric field E is moving across the distance dS. And therefore we can calculate the Vf minus V5. Vf minus Vi is equal to minus integration. So potential 1 initial potential to final potential and multiply the integration E into dS. So Vf minus Vi is equal to minus integration. So from the integrate, definitely integrate from the I to S and multiply E into dS. So this is for the we can calculate for the potential. Potential difference means this is for the electric field. This is electric field path. So this electric field paths are the particle moving from one place to another place. So this potential is the initial potential I, this potential is the final potential F. So they are moving across the electric field with the field strength E, the distance with the dS. So we can calculate the total voltage. The potential difference is equal to the initial voltage is as a Vi, final voltage is a Vs. So the Vf minus Vi is equal to minus integration I to F to EDS. So this is for the when the particle is moving from the one electric path to another path. There will be the two their potential difference. The potential difference can be calculated by the equation. Therefore,